Our skunkworks project aimed to develop a method for encoding tracking data. This would allow for the identification of similar moments between games, a typical job for an analyst. Our journey begins in 2023. At the Statsman conference in Wembley, 2 talks were given that inspired this idea. Ahmed Al-Robi gave his talk on Stratalign, finding similar player trajectories, and Karun Singh spoke of how they used transformers to encode multiple sources of data into a rich encoding. We used 2 methods to find similar plays and built a basic system to find and display them. Our first method was to take a freeze frame every 2 seconds, work out the average positions of the players, and use this to create a vector encoding. Once we have this encoding, there are ways to find the similarity, for example, the dot product. With the rise of LLMs and the need for RAG, vector databases that can do this similarity are increasingly common. We used pgvector for Postgres. We also added a clustering result to potentially speed up the query times. The results for such a simple method are surprisingly convincing. Our second method was to use a neural network to encode the plays. Our training task was to shuffle the play in time 50% of the time and ask the model to predict whether it had been shuffled or not. We take the final output of the model before classification and use that 64 length vector as an encoding.
I saw the Karen Singh talk too, so I was excited about trying to reproduce these results. But at the moment, as I'm sure many folks are, I was feeling under pressure to deliver regular work and didn't feel great about taking time away from that work to work on something unfamiliar. But in retrospect, that was exactly what I needed. We didn't want to be blocked on getting access to infrastructure, so we picked simple tools that we can easily operate on our own computers. We used our fancy tech budget on pgvector, which is just an extension on Postgres, and Amazon have stated that it works on RDS. We have a nice development environment for the project, in which we can easily load data stored locally in a Postgres DB for use by the web app. We agreed on the general shape of the model outputs on the first day and kept in sync throughout the week, and a daily stand-up each morning was very motivating. We kept the focus small so we could deliver a working feature in the time available. We made even simpler versions to begin with to make sure we'd have something available at the end of the week.
Interface for finding similar plays. We can enter a match ID and then a segment ID, which corresponds to the time in the footage. And then we say find similar, and it will load us some GIFs from some other matches and some other times where there have been similar plays. We can also use this query parameter to query different types of models. And we also have buttons for finding random plays and also finding the most typical plays within a cluster.